Good morning, 7th grade. I hope you are well and that you had a relaxing Easter weekend. Before we get to today's lesson, I want to point out a couple of things. Number one, I have graded last Monday and last Tuesday's OneNote work and have entered those grades into Praxis School. If you didn't do the work from last Monday or Tuesday, you'll notice in Praxis that you are listed as incomplete for those assignments, and I'll be working with Mrs. Chapman and Miss Clark to figure out what to do to get you guys caught up. I've also uploaded into OneNote Monday's answers and Tuesday's answers, so if you did that work last week, you can compare the correct answers to the answers that you gave. And if there's any confusion about that, I will be doing my office hours from 1 to 2:30 today. You can also email me with any questions. Okay, let's get to today's lesson. Today we're going to talk about a very specific situation where we have a game show. And in this game show, there is a tub full of envelopes, 48 envelopes specifically. There are 3 players on the game show, Xerxes, Yvonne, and Zachariah. And it's the final round of the game show, so they're each going to pull one envelope out of the tub. 36 of the 48 envelopes are empty. 6 have a $10 bill in them. 4 have a $100 bill in them. 1 of them has a check for $1,000, and 1 of them has a check for $10,000. Xerxes is going to go first, and our first question here is, what is the probability of Xerxes choosing an envelope with some amount of money in it? So the first thing we need to do, since this is a probability question, is establish our denominator. Our denominator is the total amount of possibilities that can happen. How many different possible envelopes can Xerxes pull? He can pull from 48 different envelopes. So let's put that here as our denominator. And now we need to figure out our numerator. The numerator, as a reminder, we want the thing that we want to happen. The thing that allows us to win is going to be our numerator. And in this specific problem, we want some amount of money. It doesn't matter if it's $10,000 or $10 or anything in between. We want to know what's the probability of him pulling any amount of money. Well, we've got 6 that have $10 in it, 4 that have $100, so that's 6 plus 4, that's 10, and then 1 that has a $100 check, $1,000 check, and another that has a $10,000 check. So 6 plus 4 plus 1 plus 1. There are 12 envelopes that have money in it. So the probability of him pulling an envelope with any amount of money is 12 out of 48. There are 48 possible results. Of those, 12 meet our criteria. 12 of them have some amount of money. So our probability is 12 out of 48. Once we have that, we need to check if we can simplify. Well, 12 and 48 are both divisible by 12. Ignore that noise. 12 out of 48 are both divisible by 12. 12 divided by 12 is 1, and 48 divided by 12 is 4. So, the probability of Xerxes choosing an envelope with any amount of money in it is 12 out of 48, which simplifies to 1/4. All right, let's continue on in the story. Xerxes opens his envelope and it is empty. The envelope is not put back in the tub. He's opened it. We know what's in there. There's no point in putting it back. So Xerxes just stands there with his open, empty envelope. And Yvonne steps up to the tub. Now, we have to rethink our numbers. How many envelopes are left in the tub for Yvonne to draw from? Well, there were 48, and Xerxes pulled one of them out. So now there are 47 left. That's going to be our new denominator. And let's look at what we want to happen for Yvonne. What are the odds, okay, that's going to add an extra step that we'll come back to later, that Yvonne will pull an envelope with any amount of money in it? So this is basically the same win condition as Xerxes. We don't care how much money Yvonne gets as long as she gets some amount of money. And the numbers haven't changed for our numerator because Xerxes pulled an empty envelope. He didn't get any money. So the money envelopes are all still there. And we know from the previous question, 6 have $10, 4 have $100, 1 has $1,000, and 1 has $10,000. That's a total of 12 envelopes that have some amount of money in there. So that's going to be 12 as our numerator again. So our probability of Yvonne getting any amount of money is 12 out of 47. And it's 47, remember, because Xerxes pulled an empty envelope, and that doesn't go back in the pot. But we want this answer in odds, not as a probability. So what does that look like? Well, remember, odds are always losers on the left and winners on the right. So how many ways are there to win? Well, that's going to be the same as our numerator. We know that there are 12 ways to win. There are 12 envelopes with some amount of money in it. So I put that on the right because that's where winners go. But what about on the left? Well, if there are 47 possible results and 12 of them are winners, all the rest of them must be losers. 47 minus 12 is the number of losers we have. 47 minus 12 is 35. All right, that's our odds. Yvonne's odds of pulling an envelope with any amount of money is 35 to 12. 35 ways to lose. That's 35 empty envelopes because Xerxes pulled one of the empty envelopes. Now there's 35 left. 12 ways to win. 10, 100, 1,000, or $10,000. All right, final question here. We have Zachariah. Now, before Zachariah steps up, Yvonne opens her envelope. And Yvonne's envelope has a check for $100 in it. She won. Awesome. Good for her. Now it's Zachariah's turn. And we're going to do probability again. Probability, the first thing we want to identify is our denominator. Let's think about this denominator. Xerxes started off with 48 envelopes, pulled one out. Then Yvonne pulled and took another one out. She pulled out one of the envelopes that had $100 in it. So we started with 48. Xerxes pulled one out. Yvonne pulled one out. How many are left? There are now 46 envelopes left. And our win condition here is an envelope with 1,000 or more dollars in it. How many possible ways can that go? Well, there's still this envelope with 1,000 in it and this envelope with $10,000 in it. So there are two envelopes that meet our requirement. Our requirement is $1,000 or more. There's one envelope with 1,000 and one envelope with 10,000. So our probability is 2 out of 46. 2 of the remaining envelopes have 1,000 or more dollars, and there are 46 remaining envelopes because 2 of them went away with our previous players. Now, we can always simplify, or we should always try to simplify. 2 and 46 are both even. Both of them can be divided by 2. 2 divided by 2 is 1, and 46 divided by 2 is 23. So the probability that Zachariah, going third, will choose an envelope with $1,000 or more dollars is 1 out of 23. The homework that you see today is going to have a very similar setup to this. It will not be the exact same numbers. And then you're going to have a series of similar questions to these, not the exact same questions, but close. As always, do your best. Remember, the homework is due by the end of the week, so if you aren't able to get to it today, because I know OneNote is having some technical issues, no worries. Just have it done by the end of the week. And if you have any questions, I will be on office hours on Zoom from 1 to 2:30. Remember, wash your hands, stay home, stay safe. I hope to see you all soon. Bye.